Welcome to the second lecture of the fourth day of the PETS module. We are going to continue our discussion on databases and privacy. We are now going to talk about K-Anonymity. My name is Leonardo Martucci, and I'll be guiding you in this lecture. As you have already seen, it's not easy to release data. Data anonymization is a very difficult problem. We have seen that from two examples that I presented last time, so here I reproduced one of them. The release of a data set of many users, and that was de-anonymized because the anonymization process in this case was done using pseudonyms or just by replacing usernames with unique pseudonyms, and therefore it was not that complicated for the journalists to track down or who were the users behind those pseudonyms. K-Anonymity is a solution that tries to solve this problem of releasing large data sets containing personal data. A fundamental block of K-Anonymity are the types of identifiers that exist or how they are classified. The paper that describes K-Anonymity defines two of them: explicit identifiers and quasi-identifiers. Explicit identifiers are identifiers that are uniquely attributable, such as your name, or your phone number, or even your address. In this case, we have Alice, whose surname is Carlson. This information is connected to her. She has a phone number, which is also connected to her. And she has an address that's also directly connected to her. So any of these three pieces of information are explicit identifiers that are linked directly to Alice. Mobile phone numbers, for instance, are used by secure messaging applications when they identify their users. If you think about WhatsApp or Signal or Telegram, users are identified by phone numbers or mobile phone numbers. On the other hand, we have quasi-identifiers. Quasi-identifiers, they're not precisely identifiers, they're not explicit identifiers in the sense that they can directly point to you, but a collection of them or in combination of them can actually identify an user. So in this case, we have three, or in my example here, we have three quasi-identifiers: birth date, gender, and zip code. If you take all those three attributes of Alice, for instance, she was born on 1st of July 1980, she's a female, and that's her zip code, or her address or her zip code, then those three together would pinpoint to Alice, because most likely, or there's a good chance that she's the only female born on the 1st of July 1980 that live on that zip code or that address that we try to specify. To prevent the re-identification of individuals when releasing data, K-anonymity was proposed, with a particular objective to prevent the combination of quasi-identifiers for re-identification of users. K-anonymity has a property, what's called the K-anonymity property. So on data release, information about a subject or an individual that's part of this database cannot be distinguished from at least other K-1 individuals. It means there is an anonymity set for individuals when their data about them is released. Let me explain what K is. So here I have like two examples for you. So if you say that the measure for the anonymity set where the minimum anonymity that you want, or like the K-anonymity with 2, for instance, or be a 2 anonymity or case 2, then to the left we have 3 individuals in that set. So it means that K equals 3. Therefore, it is okay for a minimum K and K2. On the other hand, on the right side, we have K equal 1. It means there is only one possible individual in the set. If K equals 1, then there is no anonymity. The idea here is that you, as the one responsible for the database, can set those thresholds, where the minimum possible that you can set for releasing information in a privacy-friendly or privacy-preserving manner is to have K equal 2, and no less. K equal 1 means no anonymity at all. Let's start with an example. Here I have a database, or the contents of a database, that is being displayed. We have a name, and to the name on the left we have the name of the individuals. So you see Alice is there, Bob is also there, so are the policeman, the fox, the nurse, and some others. All of them have their birth dates, gender, the zip code where they live, their civil status, and let's say this is a database for medical information. So therefore I have two additional information columns there. So the duration of the study and the type of diagnosis they have been diagnosed for. So let's assume this is a database for a research center or from a hospital. If you want to release this information, the first thing that you have to do is to remove the explicit identifiers. In this case, the name. So the name, they're removed. So instead of having Alice and Bob and nurse and policeman, now you have random numbers, for instance. The next field that we have to look at, the next field we want to look at is the birth date. One idea behind K-Anonymity is that columns or like information into the database can be generalized. It means you can change the semantic level of the information. So in this case, I have specific dates that I think is unnecessary for me to release like that. So I can generalize this birth date to a range of dates. In this case, to the decade that the subjects in my database were born. So if Alice was born in the 1st of July 1980, so now from now on she was born in the 80s. The same for Bob, which was born actually in the 70s, and the fox, which was born in the 90s. The next field we're looking at is the gender field. Let's recall that you're building a k=2 release, so the minimum amount of K-anonymity that you're producing is 2. So for every data query that you have, should be at least 2 entries into the dataset. In this case, you have a problem on the gender field, because if you look at the table, there is only one male that was born in the 80s. So there's a problem here. If we release data from this database, there is only one entity that was born in the 80s that's a male. This means k=1, so we cannot release dataset as it is. To solve this conflict, we have 2 options. The first one is to generalize the gender field. So instead of having the gender field specified, for instance male or female, you can replace it by generalization. And in this case, since they're like all ghosts, I replace male and female by ghost. So the gender field is generalized. If you think about like semantic levels generalization, if you talk about people, you can also replace ghost by people or person or something like this in this direction. Or we can suppress information. So an alternative here is just to eliminate this data entry from the data set that I'm going to release, because this data entry is not k=2. Or if I want to have like something different, k=3, I'll probably require a larger database, because right now we have k=2. It's not a k=3 database. The next field that we're going to look at is the zip data or the zip code data. Here we want also to generalize because we consider that to be too specific. So we remove some information that we have there to build a k=2 release. So in this case, we have to have at least 2 of them that belong to the same category. So in the case of 1970s, now I have like 2 males that were born in the 70s. Then I have their zip codes that start with 1. In the case of the subjects that are born in the 80s, which are all ghosts or persons, or because we had to remove if they're male or female, in the case of generalization of the gender field, then all their zip code starts 10. And for the ones that are born in the 1990s, then all their zip code starts 12. And if finally look at the civil status field, then you're lucky here because our civil status field is already k2. So we don't have to suppress any information and we don't have to generalize any information in the k2 field, because we have both that are born in the 1970s, they're male, with a zip code starts with 1. The same for the ones that were born in the 1980s, which are all ghosts or persons. All their zip codes starts 10, star, and they're all single. And for the ones that were born in the 90s, that are both female, and their zip code starts 12, and their civil status is both the same. It's complicated. Note that the ones that are born in the 1980s have a k=3. K will be 3 in their case. But since our data release for k=2, It's okay, it fulfills the requirement. For the release of the entire dataset, this dataset is k equal 2, because there are at least 2 subjects in each of the categories. Of course, K-anonymity is not perfect. It has its flaws. 2 works in academia try to address those problems. The first one is L-diversity toward the left. L-diversity addresses 2 attacks on K-anonymity. They're called homogeneity attack and the background knowledge attack. Addressing those problems makes K-anonymity better, but it also has its own problems. L-diversity is difficult, sometimes a necessary measure for you to protect your database or to protect the personal data in your database. It's insufficient. It does not prevent other attacks such as attribute disclosure. And attribute disclosure is related to the overall data distribution, and it also do not consider data semantics. So data semantics is really important. So for instance, in our case above, we talk about diagnosis. If I know that diagnosis or the diagnosis that I'm trying to anonymize is something related to a heart disease, then for me it's enough to know if this person is in the database or not necessarily which category he or she is. To address this, T-closeness was proposed. So it addresses those limitations on L-diversity, and the metric in their case, or in the case of T-closeness, is the information gain of the attacker, which is quite interesting. It's a very interesting approach. But it has serious limitations on the utility of data releases, and also other details, like there's no computational procedure for T-closeness if you want to really implement it. If you want to know more about any of those techniques, I'm posting here the papers about them. Links to those papers will also be available in our course. The first paper on K-anonymity, the paper on L-diversity, and the paper on T-closeness. And that will be it for K-anonymity. On the next section, we're going to be talking about differential privacy. Thank you for now, and see you on the differential privacy lecture.